Well, good morning, good afternoon, good evening, wherever it is, whatever time of day it is that you are sitting down to enjoy spending an hour with Greg Mayfield, uh, courtesy of the good folks at the Water and Wastewater uh, Trade and Transport Show in Indy. We're going to have a request for the people in Indianapolis who obviously are as seriously affected by the current COVID-19 situation as anyone else, but we'll post that here at the end of the session. I want to show you a quick little video. It's just 2 minutes, and it really, I think, gets to the point of why we're here and why we have the background image on the screen right now. Keep our fingers crossed that we don't have any buffering. If we do, we will just move on to Greg's presentation.
Have you ever thought about the soil beneath us? Did you know that the rise and fall of civilizations depends on soils? Or that there are more living things in 1 teaspoon of soil than there are people on the planet? We rely on soil for many resources, not least food and water. But soils can take thousands of years to form, and they are fragile. We are damaging it in many ways. If we want to protect our soils, we need to understand them.
Soils are amazing. They're complex and full of life, and yet few of us give soils a second thought. In this course, I'm going to take you on a journey through the world beneath our feet. We'll start by learning about the basics of soil science, what soil is made of and how soils are formed. We'll also look at the variety of soils around the world. We'll find out about why soil is so important and about the life within soils. Finally, we'll look at threats to soil and why we need to be doing more to protect it. Throughout the course, you'll have the chance to learn about cutting-edge research in soil science taking place here at Lancaster University.
So, if you already have an interest in the environment, this course will be perfect for you. You don't need any specialist expertise or knowledge, and it's open to students from anywhere in the world. You will get the chance to participate actively by joining discussions, taking part in quizzes, and getting your hands dirty with activities related to the soil where you live. By the end of this course, you'll have a basic understanding of soil science and some of the threats to soils. Join us and learn that soil is more interesting than you might think.
We thought this was a really appropriate inaugural class for the wet series because this is Earth Month. And I think environmentalism starts with protecting the very stuff that makes life possible on this planet, our water resources, our clean air, but also the soil, because without that, we won't be able to grow enough food. And I think sometimes we hear a lot of misconception muttered about wastewater systems and about on-site wastewater systems in particular. I put the link to the Future Learn Soils course there in the chat window. This is a free online course. You can click on that live link afterwards and sign up for that and be able to tell people about the millions of years it took to create the stuff that we are actually going to be talking about here today. Let's switch to our main screen here. And Greg, I'm going to ask you to start your webcam, but pause it, please. Okay, we have a little introduction here from the folks
My name
at
is Greg
WET.
Mayfield.
And do remember as we go through
Florida.
on this little symbol down here.
Happy to present here and be a part
is just to remind you that if you need to see any of these in full
Hello,
screen,
my name is
hover your
Douglas
mouse
Lugo,
over the
the
top
director
right
of the
corner
Wet
and you
Show,
will see this
and I'd
image.
like to welcome you to the
Let's
session.
hear from Douglas Lugo.
The Wet Show team has put together a series of CEU qualification classes that we hope you will find helpful. These are uncertain times. It's extremely important to be up to date on how the wastewater industry has been affected during COVID-19. The Wet Show team has launched the Wet Plus initiative as a one-stop shop for resources meant to help our industry stand tall. Please visit our site, The Wet Show, that's www.ettshow.com, to access these resources. And remember, we are essential. Thank you and enjoy the session.
And one of the things that we're going to be asking you to consider when we get to the end of this session, if you've attended the Wet Show, then you'll know that this is just as much a social gathering as it is for training, for looking at things on the exhibit floor, for getting together with your colleagues. The entire city of Indianapolis is closed down. The convention center has not been in business since March 17th. And this is obviously created an incredible economic burden for all of the service industry folks who help make going to the Indy Wet Show a really enjoyable event. There is a virtual tip jar that's been created where if you've been to a particular restaurant.
My background is I worked for the health department for the state of Florida in the 90s from 97 till about 2001. And then I worked for the Southwest Florida Water Management District as a hydrologist in their program till about 2004 as a project manager. Meanwhile, I was doing soils and engineering for different type systems with other contractors, about 15, 16 different contractors here in Central Florida. And over that time, I've learned about different systems and try to provide solutions for different things that were out there for us. I've opened up my own installation company. It's Tampa Septic. We have a group of guys here that are real good, and they get trained on these types of systems, and we install quite a few of them. So be happy to discuss them with you. The first one that I'll talk about is we'll go over some of the pictures that I have. In the bottom left corner here, oh, actually, we're gonna get this one up here. Okay. Some of the things we're gonna talk about is there's some products that we have that are made by conventional type septic systems that lower the mound from a conventional rock and pipe system. The conventional rock and pipe, it is typically 12 inches thick, 3 foot wide here in Florida, and some of the chambers that we have are 20 or 24 inches wide, and they're only 8 inches tall, which trims up and makes things smaller. Then we're going to go into some aerobic systems, and then those aerobic systems, what they do is they allow us to go to a drip irrigation system. So I'm gonna talk about drip systems, and then we've got some performance-based treatment systems, which are innovative systems that we have that allow us to treat water to go into alternative type systems. We're going to particularly talk about the GeoMat system and how the GeoMat system fits into to the Florida regs and how it works. So let's go ahead and get started. This particular project here was for a church that we did where those are infiltrator tanks, and that is a infiltrator low profile product. And that's the product that I was talking about. I believe that one's 22 inches wide and 8.5 inches tall. So it's quite a bit smaller than your typical rock and pipe system, the conventional system. But This is still a considered conventional septic system here in Florida. It's probably put in quite a bit more than a rock and pipe system nowadays. This is a typical septic tank where you have your sludge in the bottom, you have your clear zone, and we have our scum layer and liquid layer. You see our outlet filter here also that is going out. This is how a lot of guys ask me when we should have our tanks pumped. This is from Terry Bounds out of Durango, where he shows a pumping interval compared to the number of occupants that you have, the more frequently you actually need to pump out your tank. So a lot of people ask me, when should I pump my tank out? I always ask them, how big is your tank and how many people do you have in it? And then it tells you basically when you should. Of course, the rule of thumb here in this state, we always use anywhere between 3 to 5 years. And that typically works out for your typical 900 to 1,000 gallon tank. This is another install where we're, it would have been a probably like a 6 or 8 inch mound, and now we're going back in just a little bit below grade there with our infiltrator product. We have a system called PTI. It's another system. It's only 20 inches wide. It's a bundle of pipe, 5 on the bottom, 4 on the top on this one, and it actually makes the size of the system smaller. What I did here is, if there was a rock and pipe system, the system would have been as big as that trench is dug out. But we showed how we can reduce the size of the system with this system. Now we're going to talk about aerobic treatment units. And there's several different types of them out there. This one's what we call a Norweco unit. This is a Norweco singular green. It's what we have to have in order to do drip irrigation is aerobic treatment. We're going to show some pictures of the biomicrobics unit, and we typically will install one of these two systems here in this state. This is at a service station out on one of the major highways. What we did here is they really couldn't fit the mounded system in the constraints that we had. So we ended up going to a treatment system here and then to a drip irrigation system. And that drip is, you can follow the contour of the road and everything else that was on this site. It really made the site work well. Talk about aerobic units also. This one is it's the extended aeration system. I believe this one is a biomicrobics, or it's a Cajun Air, one of those systems out here. But what that one is doing is treating it, and then we're going into the drip irrigation into the landscape. And you can see that we're following the landscape beds with the tanks, and then we put the drip out in the grass, out to the edge. So here are aerobic treatment units. We have what we call our standard system. Then we have a secondary treatment where you get somewhat we call the A2U treatment. And then we have what we call performance-based treatment systems, where we treat to a better standard. And a lot of times you'll do that for, get more house on a lot, or you have constraints to a water body and those kind of things. It actually reduces the regulation from distance to the water tables, and also to the water bodies. So let's talk about the drip irrigation systems. So here we're showing the Geoflow drip irrigation system. Geoflow on this typical one is this one is a WFPC, is the waste flow controlled, it's pressure controlled. So it actually allows the wastewater to go out evenly throughout the whole system. On this one, we have the spacing out of every 2 feet. It's a 2 foot separation in between the drip and 2 foot between the emitters. So when it doses out, it pressurizes the entire drip irrigation and allows the water to go out. This bed would have been about 50% bigger if it was a conventional septic system. This particular unit was at a strip mall, and they didn't have the room to put in a regular septic system. So we actually did a biomicrobics unit on this one, and it went out into a drip bed. This one is a system that we did for a children's home. This one's actually a Norweco unit where we had a 1,500 gallon per day Norweco treatment system, and it was for 2 cottages for the homeless kids that they are orphans. And then this system, what we ended up doing is we donated much of this system to it. Geoflow actually donated the drip tube to them. And the treatment system would have cost quite a bit, but it was a nonprofit organization that we helped them out, and we did a system. It still works today. We actually do the maintenance on it, so it's a pretty good system. And this one reduced the size of the mound quite a bit, and we were able to fit more cottages into this location. We've now got up to 6 cottages, all on treatment, all on drip, and donated by individuals in our industry. Something to say, the EPA has said that, decentralized sewers and wastewater systems are adequate, and if they're managed correctly, they're cost effective and they're a long-term solution for our needs that we have. So some people say, well, septic systems are just it's not a permanent solution. They're just waiting for sewer to get there. The EPA says that no, it's actually a viable solution, and wish more states would get on board with that and allow the septic systems to do their job, and allow some of these innovative technologies to get in place and allow them to work. So this was actually at an Audubon facility here where we did a treatment system that went out into, it was on a protected water body, an outstanding water body, a cottage, and they actually wanted to they wanted to do some extra treatment. So we actually did a treatment system here and went out into the drip tube. It was along a river, so it was fairly wet. So we ended up, instead of having a 30-inch mound here, we had about an 18-inch mound. So it really reduces the footprint by about 50 to 60% when you have your shoulders and slopes and everything else. We actually we shrunk the footprint down by about 50% on this one. When we're going out to the septic systems, they require pumps. Here's a pump set up for where we're doing treatment through the system, and then we have a duplex system that's pumping out to the drip tube. This one's I don't remember which project this is, but this is a typical the pumping system where we're pumping out to the drip tube. This one's at a Circle K, which is, I don't know if you guys have Circle Ks, but they are a fast, kind of this convenience store type use. This one, they had replaced their system 3 or 4 times. We went in with several Norwecos on this one and cleaned the water up, then went into a drip irrigation system. This project was a daycare that we did, and we needed to have setbacks to a water body that was there. They needed 75 with a conventional system. We got it knocked down to a 50%. We had to meet what we call advanced secondary treatment standards, and we used a biomicrobics unit on this one, and it's doing great. I still maintain this one. It's probably 10 or 12 years old now, maybe a little bit older than that. And this is the setup where we have our treatment going into 2 fast units. These are 2 microfast 900s where we go into a lift station and pump it out to the drip tube, that drip bed that you just saw. So it works well. It does a great job, and we reduced the footprint on this one about 50% overall. On some of the bigger projects and bigger flows, we have filters that Geoflow makes, and we have to go through these headworks. We've done several up in North Carolina where we have these filter housings and their own skids, and we get the treatment going through a treatment plant, and then we go through the Geoflow filters and then out to our drip tube. And we've done subsurface and we've done above ground drip in North Carolina, just depending on if it's DEQ or I believe it's DNR up there. So the filters have what we call GeoShield. It's a system that helps prevent slime buildup, the bacterial buildup on those filters. So something to think about when you're laying out your system. You got to look at what your lot lines are. Where's everything going to be located at, and how your tree is going to be, and what your contour is. That's why drip irrigation becomes a great solution, because it can get around trees. It can go down contours. You can if you design it where you're following the contours, easily to go around those contours and make it flow. Here in Florida, everything's pretty flat, except I live in the hills up here north of town, where we actually have some slope, and it's not uncommon for us to have to use what we call drop down systems, or these drip irrigation system comes out quite well. Or what a lot of installers here do is they end up installing quite a bit of sand to level everything out, and it becomes really cost prohibitive, and the systems end up having problems. So try to follow the contours of the installation, and using drip makes it work very well. So in the drip tube itself, it has what we call GeoShield. It's a patented technology that's antibacterial, that basically doesn't allow it to build up on the drip tube itself. Something similar to Teflon, where it basically it allows things to slough off. So that way, when you're flushing the drip out, it doesn't stick on it. It goes ahead and flushes back into your treatment system to be retreated and sent back out again. So there's also what we call root guard. It's a bit of a herbicide that goes inside the drip emitter, and it doesn't allow the roots to grow into the emitter. I've actually seen these in place after 20 years, and come back and look at the root ball that's around it, but it's not growing into the emitter. It's pretty neat, actually. So when you're covering up the system, we like to have 6 to 12 inches of soil over top of the drip tube. That way that the drip tube can percolate. It goes in a 360-degree web around that drip emitter. It doesn't just go down, it comes up. So it allows some evapotranspiration. It allows some uptake by the grass, which overall reduces the nitrogen going into the groundwater if it's being used in the soil. So again, we're just going to talk about the system has Wasteflow PC, which is the pressure compensated, and it has what we call the classic drip tube. The classic is not, you have to put pressure regulators on the system to maintain pressure, so you don't get too much water at the beginning of the system and not enough at the end. But with Wasteflow PC, if you keep the system anywhere between 10 and 30 psi or 50 psi, you get the same amount of water coming out of each emitter, and that's a patented technology that they have. Plus, you got the root guard, and you have the GeoShield that keeps the bacterial growth down inside the lines. I'm going to go through some of these so you can. So yeah, whenever you're offering the Geoflow, it doesn't just go from directly to the pump into the drip line. We have filters. We have what we call headworks. There's air release valves, and then we have the time dose controllers that are going out into the drip system. So it's a design system. They require engineering here in this state, and we design quite a few of them. We do probably 5 or 6 a month, and it's just something that we're used to now. But I tell you what, 15, 20 years ago, it was totally different. It was a brand new blazing technology, but it's really become an accepted system that we use now. So there's what we call landscaping opportunities. So whenever you're designing a system and sites are constrained, people want different things. This is a system that was designed down in the Keys where the homeowner wanted something different. So they actually ended up putting the drip tube in a semicircle or that goes around their beds of flowers and everything they grow. So it's easy to use. It's beneficial. It's something that can be designed and it reuses the water and makes a cleaner environment. So this one I put in for the developers. We have some where if we do treatment, we can reduce the lot flow allowances going to a system. If you're using conventional septics, you have to design each and every home with a septic system with a tank, and you can do that. And the density of lots are quite a bit. Not as you can get more. You get less houses with a conventional septic system. And then if you do a treatment system in that same area, you can almost double the size of your system of your houses going in. And then what you end up doing is you do treatment on each lot, and then you do what we call cluster treatment centers, and then you can go to the drip out into common areas. So something that you can think about doing. We do quite a few designs like this. We did one up in North Florida, up in Gainesville area. It's pretty neat. We've done several in North Carolina. Opportunities for schools. If you do treatment and then go to a drip irrigation system, you can irrigate parks. You can go to the soccer fields, the football fields. It's great for the reuse, and it's great for the nitrogen uptake, keeps the grass green. So things to think about why you want to use a treatment system. It's if you go subsurface, we'll probably move on to this other slides because I just want to talk about some other product too, and I'm getting about halfway through. So let me see. I'm gonna move through here. Yeah, there you go. We have some, you can use it for municipal. We actually did one in Orlando, similar to this one, and I think this is in Arizona, where we actually did reuse in the medians, where we took some of their reuse and actually put it out into the middle of the medians. It's pretty neat. All right. So also what I want to talk about is obstacles that are in the way. We have some where we've gone in between trees, and I think this is a neat picture that we have here. Okay, let's go back to. Yeah, there you go. So we have look at this. You can see how the drip tube here is on the left hand side. We're all in rows, but then the trees are in the way. We just slide around the trees and make it work, and it's actually good for the trees. And it with the root guard, you don't get the emitters clogged. So this is talking about the Geoflow and advantages of Geoflow. We have some other products. I'm gonna move over to another one of our other presentations. That way you can see some of the GeoMat product that I've been discussing too. So on the left-hand side, what we have here is the GeoMat product. GeoMat is developed out of by GeoMatrix. They're located up in Connecticut, and they've just been permitted here in Florida under what we call the Innovative System Permitting, what we call the ISP. It's a demonstration way of demonstrating these systems and to see if they're going to work here in Florida. They work all up in the Northeast, but here this system, it's basically a 1-inch mat that's 1 inch thick and is 39 inches wide, or you can get it in 12 inches wide. But mainly what we do here is the 3-foot wide product. And then it has a low pressure dosing system that actually we pump regular septic tank effluent, or you can do treatment, which makes it a better system, but you can actually do a just regular septic tank effluent into this GeoMat. Then it's a low pressure dosing system that goes into it and to the very end. So we have what we call our low, this is one of my spreadsheets that I use for what we do is our low pressure dosing system. This basically does the calculations for our low pressure piping that goes into any system, particularly the GeoMat in this presentation. This is a design that we did for this is a strip mall where we went in to do a repair. They had paved quite a bit of their area around the system. So what we're doing is making the system as small as we can, and with a low pressure dosing system, and being only 1 inch tall, we didn't have to build up a mound here. So we would have had to have a 10 or 12 inch mound. With a regular system, with the GeoMat, it becomes a no mound system. It basically went below the grade there. And that's the complete site that we have. We have constraints down here at the bottom where we are actually they have a little pond here, and then we had to get our setbacks from the pond. Very tight lot, very tight situation. But with the reduction in size that we got, and with the low profile, it just makes it it makes it a no-brainer. Now this is our ISP permit. This is sent from the state health office, where it actually gives us the right to install it in what situations we can install it in. So it's a system that each system has to follow these guidelines under that ISP. So you can see here that we have what we call the GeoMat 1200 and the GeoMat 3900. These systems come in 12-inch widths and 39-inch widths. The 12-inch width, or the 1200, can be installed in a flat, or we can actually do what we call edge, where they're actually turned up on their edges and they'll be 12 inches thick, and you basically reduce the footprint over reducing the height. So there's different ways of installing that system. Mainly, I stick with the 3900. We do the systems that are wider and longer, and it's just I like it better. And here's where you have what we call the loading rates, or basically the square footage that it gives per lineal foot. So the 39-inch product actually gets credit for 4.56 square foot for every lineal foot. And for different soils, you have different orientations and different ratings. So if you look at it, this is the flat system where we actually are, we have the product in a flat on the grade, and this is how it looks in the cross section, versus in a system where we call it edge, where it actually you turn it on its edge and you can put the system in there. This reduces the overall length of the system. So something for the regulators to look at, because a lot of these regulators, they don't even know what they're looking at. These systems are brand new. So what we try to do is we educate them on the types of systems that are out there and what we can do, and we go over it when at permitting. And then also what we usually do is when we install some of these new and innovative systems, what I do is I invite them out to our job sites, and we'll have 3 or 4 or 5 different health departments there, and they can see those systems and get their inspectors trained, because knowledge is power, and we want them to know what they're getting into when we're putting these systems in. All right, this is a system where we actually installed a Norweco treatment unit. This is a performance-based treatment system. If you look at the system has a lot of site constraints. They have the seawall that's on the very back of the property, and then they have a ditch that runs along the edge of the property, and we have to maintain that 50-foot setback. So in order to do that, we did a performance-based treatment system and installed drip irrigation to fit everything in on this one. So that's just kind of how the systems we end up with these systems that require treatment, and a lot of times it's you have the treatment, you need to go to drip, it reduces the size and the footprint. But if it's just a height wise, then we use the GeoMat, where let's say somebody has a 20-inch mound, they want to lower it, we can lower to 11 inches and with just GeoMat. It doesn't change the footprint as much as drip with treatment, but it does reduce the size compared to a conventional septic system. So we blew up this unit. If you look in the bottom left, is that ditch that I'm talking about running down the side. We also had a ditch, and it got whited out here, looks like a little bit, but there is a ditch that comes down through here, and then that we're keeping our 50-foot setback. So if you look at the cross section in the bottom right corner, you can see once you do treatment and you go to drip irrigation, it reduces that overall mound height. And it's typically a footprint reduction of anywhere between 50 and 60% of your overall footprint, toe of slope to toe of slope. Many times what we do is we have systems where people have constraints, where this house being built, they wanted to have a pool and a portico, and they wanted to have a bunch of things in the on site. So what we did is we designed a system to put it in the very back corner to try to hide it. And this is a GeoMat system where we designed it for the GeoMat and lowered the system down and put it in the very back corner as far as we could. This is a GeoMat system we're going through permitting for currently, actually, and this one's it's an existing system, about 36-inch mound, and we're going to lower it down to a 25-inch mound. So it's reducing the height of the mound, but overall that actually reduces the footprint around it also. If you look at the cross section on this one, you can see that it's 39 inches wide. 39 inches wide here. And Ginger, where's my pointer at? Yeah.
It's in the top. Yeah. If you hover over the top of your slide, it will come up. Yeah, so if you look right here, you can see how it's 39 inches wide. And then we have our 1 foot shoulder, and then we have our 5-to-1 slope. It actually reduced this footprint by about 8 to 10 feet in width across this system. And if you look at the overall area over here, instead of it being 40 foot wide, it was actually reduced down to 32.4 foot wide. Quite a bit of a reduction in size for the system. Try to show that as a kind of it's an overall footprint of how it works. It's pretty neat. If you notice down here, we also
we have to stay away from our seasonal high water table. This one's a newer system, so it has to be 24-inch separation from that seasonal high water table here. We have under repair codes here in this state, they have a 24 for systems older than 80 or from 83 and younger. And then systems that are older than 1983, you get a 6-inch separation. So if it's a repair and the system's and it's an 86 or 88, the bare minimum is 12 inches if they don't have that 24-inch now. So they could have as little as 12 inches at that point. Pretty neat. They allow some grandfathered in, which is not a bad idea in the standpoint of a lot of houses are built closer when they're older, and having a mound in an older house, we've seen flooding on different houses, and having systems that you can lower that mound and lower that impact of flooding is crucial. And that's when we use these systems. This is a system actually that we actually are replacing a system by No Mound. No Mound did a system here, and the bladder actually blew out, and it's hard to find parts and guys that service it. So what we're actually doing is going back in with a GeoMat system here. We're designing that with a GeoMat, where we can still fit it in that center area of the drive-through and drive around, circular drive. And if you look at this, is a close-up of that circular drive that we have here, and it is, where we have that circular drive, we're putting that system in and fitting it in there. We're having to pull out all the old no mount system that is in there. So something else to talk about when we're designing these systems. Typically, we use a low pressure dosing system that goes throughout the drain field area, and we like to use either the Semtech filters, or you can use the BioTube filters by Arenco. They're very nice, and we use a lot of the Arenco controllers that go out. They're just a better widget. We like them. We design quite a few of them with it. It works out quite nicely. This one's a GeoMat specific product. Something else we have to do here is we have to make sure that we're not putting more than 0.75 gallons per day into any lineal foot of drain field. So we have a calculation that shows we're not doing that. That's specific to this technology. The rest of it's pretty much the same as a typical low pressure dosing system that we did. And I have to thank Dr. Roeder. He's Everhard Roeder from the Florida Department of Health. Him and Dr. Gao, they actually came up with this spreadsheet. They shared it with the rest of the designers that we have out there. So it's if anybody needs that, we have it. I'm sure you can get it from Dr. Roeder or Dr. Gao. They've helped us out tremendously by helping with these designs, and it makes it where everybody uses the same kind of design. It works out. I know I've got a few more minutes. I've got some other pictures that we can share. I can show some other projects. Does that work, Dendra?
Sure, just give me a second. Yeah, give me a second here to put this one away, and we'll bring the other one in. I did want to mention though too, remember the little interaction tools at the top there. If you have a microphone, and when we get to Q&A, if you would like to ask your question in person, just let us know by raising your hand, and we will give you a microphone when we get to that point. Let me find your presentation here. Pretty sure it's this one. Just wait 1 second here. Here we go. And I noticed a couple of people have said they had some buffering issues, so just hang on 1 second and let it load, and we should be good to go. Go ahead, Greg.
Okay. So this is some pictures that I have from some projects that we have, and I think it's always a good talking point. Um, this system here, we wouldn't have been able to fit this in with a conventional septic system, so we ended up doing treatment. This was a pawn shop, kind of a little strip mall type deal, where we actually in behind here, we actually, yeah, let me see here. Yeah, so back here in the back, we actually have our treatment, and then we have our Geoflow headworks, and then the drip all comes out into the area along the side of the building. This would have been probably about an 18-inch mound with a conventional septic system. So we made it to where it was only about a 6 inches of fill, reduced the size of it, and made it work. This system's still working today. It was probably put in probably 2010, 11, somewhere around that area. Still going strong. This one's at a Burger King that we did. This one has probably 20 or 30,000 gallons of tankage. Big grease problem they had in this site. We did 5 or 6 grease traps, 5,000 gallon per day treatment system. This one's an aqua clear unit, and we had some other aeration out in the parking lot also. And then we went to dual tank, and we did drip out in the area. We used all of their available area. This system still has problems, and they just use so much grease, and they don't have enough area during their peak flows. So drip and restaurants are not the best suited match. You have to do a lot of treatment to get it to drip levels. So that's where the design comes in. But this was all that would fit in this area. We've got it, but now they have to pump the grease traps out so frequently. It's ridiculous, but it works. If they had sewer, they'd probably connect, but they need to buy another drain field this size to actually make it work. They just don't have the room for it. This is another picture of that Geoflow in that system. Now, this is a project that we did in North Carolina. This one we used the Advantex AX Max. That's what was designed. I typically use Geoflow. This one was designed with Metafilm, but we installed it according to the engineer's spec, and then we went out from there. This is a showing how the Metafilm. In North Carolina, they make you berm your headers, so you actually have to make what we call the dam that goes in between the drip and your headers and your pipes. That way you don't get preferential flow along your headers. And this is it, what we were covering it. You can see you get about 6 to 12 inches of cover over top of it. This is that same system that I showed you earlier, where we had the tight lot, and it's a gas station, and all the green area that we had, there wasn't enough room for a conventional system, so we did treatment and went to drip irrigation. That system's still being used today. We still have the maintenance contract on it. This is a tight lot on the Alafia River here in Hillsborough County in Tampa, and they didn't have enough room for their drain field and their driveways that they had, and they had added onto the house and built over the existing system. So we ended up doing a very tight system, and this one's a Norrico green, go into a drip irrigation system. This one is for another Circle K that we did where they didn't have enough room, and we did treatment here into a drip irrigation system. This is an existing mound that we ended up lowering it, and we're able to go closer to the property line with more drain field than what you could do with a conventional system. This one is a AquaClear unit, and these are infiltrator tanks, and then it doses out into the drip field. And there's another picture, another angle. And then this is it after it's covered. This is a large house on Lake Magdalene in Tampa. If you notice, the lake is back here, and very tight. We did the treatment along the property line. Notice that the property line is about right here, and this would have been a huge mound for a big house, and we lowered it down to 6-inch fill job versus a 18-inch mound that would have taken up quite a bit more space. And that's the mounded system. That would have been a mounded system, and we lowered it down to just a 6-inch fill. And that's the single layer green units. This one, I believe, is another single layer green system. This is another strip mall that we did. This would have been like a 24-inch mound, and we ended up reducing it down to a 12 or 13-inch mound. Pretty neat. That's a pump vault unit. That pump vault unit then allows us to go out to the treatment. This is post treatment. This goes out into the Geoflow from here. This is an aqua clear aerator. And this one has aqua clear aeration going into where it's going to be going into a mounted system here, and we just were doing treatment. These are single air boxes. If you see them here, and this is an Aerobic control panel. We use those in conjunction doing our time dose controls that go out to the Geoflow drip tube. This lady was one of my professors at USF, where I'm actually going back to get my doctorate here in the next year or two. And this is actually a treatment system at their house. And then they're going to a drip irrigation system. That's a Geoflow system. This would have taken out, this is probably 50% smaller than what it would have been if it was a conventional septic system. Quite a bit smaller. The grease tankage here, that's grease tankage at that Burger King. If you look up in the back here, that's the aeration control panels and the control panels for the aeration system going out into the drip right here. And then these are all the grease traps. Quite a few tanks there. This one has treatment. You can see the tanks going right down through here, and then the drip is actually there. This lowered the mound considerably and shrunk up the size, and they allowed this to build a bigger. This house is, I don't know, a 4-bedroom house on this lot, and it's a pretty big house for these size lots that they had here, right on the river, and that's the Alafire River. And there you go. There's the tanks there. This is a Norweco singular green, and then a lift station here, and then the drip irrigation right there. We did a big system called Sisters Cove up in North Carolina. This was a 5-acre. This was about 40 homes, I believe, right on Lake Norman. We did an Avantex AX Max unit. You can see it down here in the corner. Then we have it go through a pump, and it has the headworks here, the Geoflow headworks, and then we did Geoflow out into the ground out here on this. About 5 acres of drip irrigation. We actually did a vibratory plow on this one, and I've got some videos of this one. If anybody wants to get the videos, we can share that with you. That's actually a ditch witch and a vibratory plow, where we actually plowed that into the ground. It took us quite a while to do that, and that's after the plow here. You can see where we plowed. That's where we installed the drip inside that area, and that there's an AX Max, we had what we call a surge tank here, the AX Max unit. And then this is a 3,000 gallon dosing tank. And then the headworks actually went right here. That's a singular green unit being installed. This is in North Carolina, where we actually show the dam going up into the drip tube. We have to actually build that earthen dam up before it goes into the drip, and the first emitter is on the other side of this dam. So it comes up and drips into the soil there. And that's a larger view of that same area that we were plowing. This is the aerial view of the zones that go out. One goes on one way and one goes back the other way. And here's the treatment unit, and that's the lift station. And then we have all of the headworks and zone valves in there for the drip. This is another tight lot over on Lake Magdalene, where we had to build the site up, and this one was about a 12-inch mound with drip. It would have been a 24-inch mound with a normal system. So we reduced the size down quite a bit. Yeah, so here you can see the tanks and the treatment are over on that side, and then the drip irrigation here. And this is built up, you can see about 12 inches or so. Then we have 6-inch covers, so that's about an 18-inch mound there. This is for a commercial job that we did. This is over in North Tampa, Temple Terrace area. And this one has all the treatment units right here. It has what we call the trash tanks up here. That one has dual trash tanks, and it has dual treatment into a large 3,000 gallon tank, which then doses out to the drip field. This is that same one in North Carolina. You can now see the contours out here, where we've actually taken the bent it there, and actually we installed more in this area coming down through here. And I think that just about does it.
Thank you, Greg. It's always amazing to me how people really don't understand that on-site wastewater systems are not a hole in the backyard that all kinds of unmentionable stuff ends up in. That I think everyone who's on this call has been in this business for long enough to know that there are multiple options for individuals. While everybody's thinking about question or whether they want to have a hand raised, I see Jennifer does. I'll give you a microphone here in a minute, Jennifer. We did have a question texted in. What is the approximate cost for a single family home mound resizing system like this?
Yeah, so if you're doing Geoflow and GeoMat, the difference is a little bit different. One requires an ATU, which is the Geoflow, the drip irrigation requires treatment in this state. So it's a little bit more expensive. I would say a typical 3 or 4 bedroom house system is around 18,000 if you have a mound and you're going to reduce that mound. And I've seen them as cheap as 13 or 14,000. Depends on different types of systems that you use. We make a better widget, I believe. We make it more maintenance friendly. So it has some I add another pump onto it. I add a duplex control panel. I make it where it's maintenance friendly, and ours is about 18 grand when it's all said and done. With the GeoMat, same size house, same mound, you're around 13 or 14,000. So they're not cheap, but it's more aesthetically pleasing. You can actually build on the lot.
And another question that came in is, with so much of the state of Florida and the surrounding states being low lying, and obviously in the picture there we've got a high degree of clay, What level of treatment are you required to reach in order to have this system?
Yeah, so the level of treatment depends on your site. So let's say that we have systems that are going in on a lake that they don't have enough room. You can do a regular aerobic treatment unit if you can fit it in. So that's a 2020 on your CBOD and TSS. Whereas let's say that you end up with a lot that you can't fit everything in and you've got to get that 50-foot setback. We do what we call an advanced secondary treatment. And that's where we'll end up using the Norwecos, the biomicrobics, the hoots. So that would be something that you would use. On the GeoMat, you typically have the room, you just don't like the mound height. So it will reduce the mound height, and that reduces the cost on having to have sand imported in. But it's still, the product's a little bit more expensive than your typical, let's say, chambers.
And there's a question in the chat.
And the treatment still is septic tank effluent.
There's a question in the chat window from Jennifer Cisneros for biomicrobics. She said, have you used the Sanity effluent screens?
I have used those, and they're a great product. So be happy to talk about those or whatever you guys need.
Okay, I see a couple other people typing questions in, and to be respectful of people's time, we're going to go for just a couple more minutes here. If anybody wants to stick around after the event finishes recording and have another conversation, that is perfectly fine. You'll see that Greg's contact information is there at the bottom of your screen. Also a poll, as you've no doubt come to appreciate that Mr. Mayfield is an expert on drip systems and drip installation. And when he becomes Dr. Mayfield, we will be really excited. But we've discussed having a more in-depth online training class for choice for site design, for installation techniques, for servicing and maintaining. And if that is something that's of interest to you, please go ahead and let us know in the poll, and we will contact you afterwards. So let's take a look. Anything else in there? At this point, Greg, I'm going to pause the recording, but everyone stick around and we can have a little offline conversation. So thank you, everybody, and thank you to WET for sponsoring this. Be sure and come back next week, where on the 23rd, we have another event from Travis Vance, who is going to be talking about the essential worker OSHA regulation and how to access information on paycheck, payroll support, and small business support, following obviously the real national emergency of COVID-19. And with that, I'm going to stop the recording. Thank you so much, everybody, and thank you, Greg.